Natural gas is a naturally occurring hydrocarbon gas mixture consisting primarily of methane. It is formed when layers of decomposing plant and animal matter are exposed to intense heat and pressure over thousands of years. The energy that the plants originally obtained from the sun is stored in the form of chemical bonds in the gas. Natural gas is a fossil fuel used as a source of energy for heating, cooking, and electricity generation. It is also used as fuel for vehicles and as a chemical feedstock in the manufacture of plastics and other commercially important organic chemicals. It is a non-renewable resource. Natural gas is found in deep underground rock formations or associated with other hydrocarbon reservoirs in coal beds and as methane clathrates. Petroleum is another resource and fossil fuel found in close proximity to, and with natural gas. Most natural gas was created over time by two mechanisms: biogenic and thermogenic. Biogenic gas is created by methanogenic organisms in marshes, bogs, landfills, and shallow sediments. Deeper in the earth, at greater temperature and pressure, thermogenic gas is created from buried organic material. When gas is associated with petroleum production, it may be considered a byproduct and be burnt as flare gas. The World Bank estimates that over 150 billion cubic meters of natural gas are flared or vented annually. Before natural gas can be used as a fuel, it must be processed to remove impurities, including water, to meet the specifications of marketable natural gas. The byproducts of this processing include ethane, propane, butanes, pentanes, and higher molecular weight hydrocarbons, hydrogen sulfide, carbon dioxide, water vapor, and sometimes helium and nitrogen. Natural gas is often informally referred to simply as gas, especially when compared to other energy sources such as oil or coal. However, it is not to be confused with gasoline, especially in North America, where the term gasoline is often shortened in colloquial usage to gas. Natural gas was used by the Chinese in about 500 BC. They discovered a way to transport gas seeping from the ground in crude pipelines of bamboo to where it was used to boil salt water to extract the salt. In the Ziliang district of Sichuan, the world's first industrial extraction of natural gas started at Fredonia, New York, USA in 1825. By 2009, 66 trillion cubic meters had been used out of the total 850 trillion cubic meters of estimated remaining recoverable reserves of natural gas. Based on an estimated 2015 world consumption rate of about 3.4 trillion cubic meters of gas per year, the total estimated remaining economically recoverable reserves of natural gas would last 250 years at current consumption rates. An annual increase in usage of 2 to 3% could result in currently recoverable reserves lasting significantly less, perhaps as few as 80 to 100 years. Natural gas processing. The image below is a schematic block flow diagram of a typical natural gas processing plant. It shows the various unit processes used to convert raw natural gas into sales gas pipeline to the end-user markets. The block flow diagram also shows how processing of the raw natural gas yields byproduct sulfur, byproduct ethane, and natural gas liquids propane, butanes and natural gasoline. Depletion. Natural gas production in the U.S. reached a peak in 1973, and went over a second lower peak in 2001, but recently has peaked again and is continuing to rise. Uses. Natural gas is primarily used in the Northern Hemisphere. North America and Europe are major consumers. Midstream natural gas flowing in the distribution lines and at the natural gas wellhead are often used to power natural gas-powered engines. These engines rotate compressors to facilitate the natural gas transmission. The natural gas transmission lines extend to the natural gas processing plant or unit, which removes the higher molecular weighted natural gas hydrocarbons to produce a British thermal unit value between 950 and 1050 BTUs. The processed natural gas may then be used for residential, commercial and industrial uses. Often midstream and wellhead gases require removal of many of the various hydrocarbon species contained within the natural gas. Some of these gases include heptane, pentane, propane and other hydrocarbons with molecular weights above methane to produce a natural gas fuel, which is used to operate the natural gas engines. For further pressurized transmission, several methods are used to remove these higher molecular weighted gases for use at the natural gas engine. A few technologies are as follows: Joule-Thomson skid, cryogenic core chiller system, chemical enzymology system. Power generation. Natural gas is a major source of electricity generation through the use of cogeneration, gas turbines and steam turbines. Natural gas is also well suited for a combined use in association with renewable energy sources such as wind or solar and for alimenting peak load power stations functioning in tandem with hydroelectric plants. Most grid peaking power plants and some off-grid engine generators use natural gas. Particularly high efficiencies can be achieved through combining gas turbines with a steam turbine in combined cycle mode. Natural gas burns more cleanly than other hydrocarbon fuels, such as oil and coal, and produces less carbon dioxide per unit of energy released. For transportation, burning natural gas produces about 30% less carbon dioxide than burning petroleum. For an equivalent amount of heat, burning natural gas produces about 45% less carbon dioxide than burning coal for power. The U.S. Energy Information Administration reports the following emissions in million metric tons of carbon dioxide in the world for 2012. Natural gas 6,799. Petroleum 11,695. Coal 13,787. Coal-fired electric power generation emits around 2,000 pounds of carbon dioxide for every megawatt-hour generated, which is almost double the carbon dioxide released by a natural gas-fired electric plant per megawatt-hour generated. Because of this higher carbon efficiency of natural gas generation, as the fuel mix in the United States has changed to reduce coal and increase natural gas generation, carbon dioxide emissions have unexpectedly fallen. Those measured in the first quarter of 2012 were the lowest of any recorded for the first quarter of any year since 1992. Combined cycle power generation using natural gas is currently the cleanest available source of power using hydrocarbon fuels, and this technology is widely and increasingly used as natural gas can be obtained at increasingly reasonable costs. Fuel cell technology may eventually provide cleaner options for converting natural gas into electricity, but as yet it is not price competitive. Locally produced electricity and heat using natural gas-powered combined heat and power plant is considered energy efficient and a rapid way to cut carbon emissions. Natural gas power plants are increasing in popularity and generate 22% of the world's total electricity, approximately half as much as generated with coal. Domestic use natural gas dispensed in a residential setting can generate temperatures in excess of 1,100 degrees Celsius, making it a powerful domestic cooking and heating fuel. In much of the developed world it is supplied through pipes to homes, where it is used for many purposes including ranges and ovens, gas-heated clothes dryers, heating, cooling, and central heating. Heaters in homes and other buildings may include boilers, furnaces, and water heaters. Both North America and Europe are major consumers of natural gas. In the U.S., compressed natural gas is used in rural homes without connections to piped-in public utility services, or with portable grills. Natural gas is also supplied by independent natural gas suppliers through natural gas choice programs throughout the United States. However, as a CNG costs more than LPG, LPG is the dominant source of rural gas. Transportation. CNG is a cleaner and also cheaper alternative to other automobile fuels such as gasoline and diesel. By the end of 2012, there were 17.25 million natural gas vehicles worldwide, led by Iran, Pakistan, Argentina, Brazil, India, and China. The energy efficiency is generally equal to that of gasoline engines, but lower compared with modern diesel engines. Gasoline, petrol vehicles converted to run on natural gas suffer because of the low compression ratio of their engines, resulting in a cropping of delivered power while running on natural gas. CNG-specific engines, however, use a higher compression ratio due to this fuel's higher octane number of 120 to 130. Fertilizes. Natural gas is a major feedstock for the production of ammonia, via the Haber process, for use in fertilizer production. Aviation. Russian aircraft manufacturer Tupolev is currently running a development program to produce LNG and hydrogen-powered aircraft. The program has been running since the mid-1970s, and seeks to develop LNG and hydrogen variants of the Tu-204 and Tu-334 passenger aircraft, and also the Tu-330 cargo aircraft. It claims that at current market prices, an LNG-powered aircraft would cost 5,000 rubles less to operate per ton, roughly equivalent to 60%, with considerable reductions to carbon monoxide, hydrocarbon and nitrogen oxide emissions. The advantages of liquid methane as a jet engine fuel are that it has more specific energy than the standard kerosene mixes do, and that its low temperature can help cool the air which the engine compresses for greater volumetric efficiency, in effect replacing an intercooler. Alternatively, it can be used to lower the temperature of the exhaust. Hydrogen. Natural gas can be used to produce hydrogen, with one common method being the hydrogen reformer. Hydrogen has many applications. It is a primary feedstock for the chemical industry, a hydrogenating agent, an important commodity for oil refineries, and the fuel source in hydrogen vehicles. Other natural gas is also used in the manufacture of fabrics, glass, steel, plastics, paint, and other products. Storage and transport. Because of its low density, it is not easy to store natural gas or to transport it by vehicle. Natural gas pipelines are impractical across oceans. Many existing pipelines in America are close to reaching their capacity, prompting some politicians representing northern states to speak of potential shortages. In Western Europe, the gas pipeline network is already dense. See also List of natural gas pipelines. See transport using CNG. Carrier ships that are now under development may be competitive with LNG transport in specific conditions. Gas is turned into liquid at a liquefaction plant, and is returned to gas form at regasification plant at the terminal. Shipborne regasification equipment is also used. LNG is the preferred form for long-distance, high-volume transportation of natural gas, whereas pipeline is preferred for transport for distances up to 4,000 kilometers overland and approximately half that distance offshore. CNG is transported at high pressure, typically above 200 bars. Compresses and decompression equipment are less capital-intensive and may be economical in smaller unit sizes than liquefaction, regasification plants. Natural gas trucks and carriers may transport natural gas directly to end users, or to distribution points such as pipelines. In the past, the natural gas which was recovered in the course of recovering petroleum could not be profitably sold, and was simply burned at the oil field in a process known as flaring. Flaring is now illegal in many countries. Additionally, higher demand in the last 20 to 30 years has made production of gas associated with oil economically viable. As a further option, the gas is now sometimes re-injected into the formation for enhanced oil recovery by pressure maintenance as well as miscible or immiscible flooding. Conservation, re-injection, or flaring of natural gas associated with oil is primarily dependent on proximity to markets and regulatory restrictions. A master gas system was invented in Saudi Arabia in the late 1970s, ending any necessity for flaring. Satellite observation, however, shows that flaring and venting are still practiced in some gas-extracting countries. Natural gas is used to generate electricity and heat for desalination. Similarly, some landfills that also discharge methane gases have been set up to capture the methane and generate electricity. Natural gas is often stored underground inside depleted gas reservoirs from previous gas wells, salt domes, or in tanks as liquefied natural gas. The gas is injected in a time of low demand and extracted when demand picks up. Storage nearby end users helps to meet volatile demands, but such storage may not always be practicable. With 15 countries accounting for 84% of the worldwide extraction, access to natural gas has become an important issue in international politics, and countries vie for control of pipelines. In the first decade of the 21st century, Gazprom, the state-owned energy company in Russia, engaged in disputes with Ukraine and Belarus over the price of natural gas, which have created concerns that gas deliveries to parts of Europe could be cut off for political reasons. The United States is preparing to export natural gas. Floating liquefied natural gas is an innovative technology designed to enable the development of offshore gas resources that would otherwise remain untapped because due to environmental or economic factors it is non-viable to develop them via a land-based LNG operation. FLNG technology also provides a number of environmental and economic advantages. Environmental, because all processing is done at the gas field, there is no requirement for long pipelines to shore, compression units to pump the gas to shore, dredging and jetty construction, and onshore construction of an LNG processing plant, which significantly reduces the environmental footprint. Avoiding construction also helps preserve marine and coastal environments. In addition, environmental disturbance will be minimized during decommissioning because the facility can easily be disconnected and removed before being refurbished and redeployed elsewhere. Economic, where pumping gas to shore can be prohibitively expensive, FLNG makes development economically viable. As a result, it will open up new business opportunities for countries to develop offshore gas fields that would otherwise remain stranded, such as those offshore East Africa. Many gas and oil companies are considering the economic and environmental benefits of floating liquefied natural gas. There are currently projects underway to construct 5 FLNG facilities. Petronas is close to completion on their FLNG-1 at Daewoo Shipbuilding, and Marine Engineering are underway on their FLNG-2 project at Samsung Heavy Industries. Shell Prelude is due to start production 2017, and the Browse LNG project has completed FEED with final investment decisions expected in mid-2016. Environmental effects. Effect of natural gas release. Natural gas is mainly composed of methane. After release to the atmosphere, it is removed by gradual oxidation to carbon dioxide and water by hydroxyl radicals formed in the troposphere or stratosphere, giving the overall chemical reaction CH4 plus 2O2 CO2 plus 2H2O. While the lifetime of atmospheric methane is relatively short when compared to carbon dioxide, with a half-life of about 7 years, it is more efficient at trapping heat in the atmosphere, so that a given quantity of methane has 84 times the global warming potential of carbon dioxide over a 20-year period and 28 times over a 100-year period. Natural gas is thus a more potent greenhouse gas than carbon dioxide due to the greater global warming potential of methane, but because when it is burned, it produces more water than carbon dioxide by mole. In contrast to coal, which produces mainly carbon dioxide, it produces only about half the carbon dioxide per kilowatt-hour that coal does. Current estimates by the EPA place global emissions of methane at 85 billion cubic meters annually, or 3.2% of global production. Direct emissions of methane represented 14.3% by volume of all global anthropogenic greenhouse gas emissions in 2004. During extraction, storage, transportation, and distribution, natural gas is known to leak into the atmosphere, particularly during the extraction process. A Cornell University study in 2011 demonstrated that the leak rate of methane may be high enough to jeopardize its global warming advantage over coal. This study was criticized later for its overestimation of methane leakage values. Preliminary results of some air sampling from airplanes done by the National Oceanic and Atmospheric Administration indicated higher than estimated methane releases by gas wells in some areas, but the overall results showed methane emissions in line with previous EPA estimates. Natural gas extraction also releases an isotope of radon, ranging in activity from 5 to 200,000 becquerels per cubic meter of gas. CO2 emissions. Natural gas is often described as the cleanest fossil fuel. It produces about 29% and 44% less carbon dioxide per joule delivered than oil and coal respectively, and potentially fewer pollutants than other hydrocarbon fuels. However, in absolute terms, it comprises a substantial percentage of human carbon emissions, and this contribution is projected to grow. According to the IPCC Fourth Assessment Report, in 2004, natural gas produced about 5.3 billion tons a year of CO2 emissions, while coal and oil produced 10.6 and 10.2 billion tons respectively. According to an updated version of the Special Report on Emissions scenario, by 2030, natural gas would be the source of 11 billion tons a year, with coal and oil now 8.4 and 17.2 billion respectively because demand is increasing 1.9% a year. Other pollutants. Natural gas produces far lower amounts of sulfur dioxide and nitrous oxides than other fossil fuels. The other pollutants due to natural gas combustion are listed below in pounds per billion BTU. Carbon monoxide 40, sulfur dioxide 1, nitrogen oxide 92, particulates 7,